Hi everyone. Welcome to our video on the quotient rule. The quotient rule tells us if we have a function divided by a function and we want to take the derivative of it, then we have this equation to use. All right, so the way that I like to memorize it, so I gave myself some space here, I think of it as a high function over a low function, and I'm abbreviating how to spell those. All right, so high over low becomes, when we do the derivative, we have the low times the derivative of the high, so low d high minus high d low, all over low low. So that's how I think of it. So we have our low function times the derivative of the high function minus the high function times the derivative of the low function over low low. Okay, so times that, and that is the same as the bottom function squared. Okay, and however way we think of it, so this is with u's and v's, but notice the low portion leads off the numerator and the denominator in these cases. So it's always start with low, so low and then the derivative of the high minus high times the derivative of the low. So kind of similar to the product rule where it alternates which one it has the derivative, but the minus is important. It has to have this order because the minus is not commutative, so order is important here. Okay, and same deal, even if you use these letters, V is first. The bottom one is always first when writing these. Okay, and they might use different letters as well. They might use F and G, so say I'm going to abbreviate it with FG like that. Well, it's our low D high minus high D low. So I'm still just saying it in words, but putting the actual symbols here over the low one getting squared, or low low. Okay, so GF prime minus FG prime over G squared. Okay, so that's the quotient rule is, so we use it whenever you have a quotient, so something divided by something, or you could use it whenever you have something divided by something. Sometimes there's easier methods. So let's take a look at some problems. All right, so we're going to find and simplify the derivative of these following functions. All right, so on this we have, so I'm going to use low and high. So if you prefer the symbols, well, you could still do them. It's just you'd have to make the adjustments. I think low and high is easier to deal with most of the time because then I don't even have to worry about letters, U, V, F, G. So those could be used in other problems anyway. So with high and low, they'll never use that. So I'm going to say this is our high function, and then this is our low functions. All right, and we could do just like we did the product rule where we can color code. So like the high I'm going to do in blue, the low I'm going to do in red. And then I'm going to set up my equation. So f prime of x is my low d high minus my high d low all over low low. So again, it has a nice kind of roll off the tongue. And then afterwards, I usually put in the parentheses to show low times the derivative of the high minus the high times the derivative of the low. And then I do low low. You could just write low squared. It's just up to you. Okay, anyway, so that's our setup. So whenever I have a quotient, I do write the formula out. I don't try to just jump to an answer. Okay, and then now I'm just going to start plugging things in. Okay, so it says the low one. So anything in the low, I'm going to highlight in red again. So the low one, so that's just x, times the derivative of the high. Well, with this, I think we could just look at it. Other problems, we might need to rewrite it to the side. But the derivative of this looks like it's just 6x. And then minus just the high one, just the 3x squared, plus 5. And then the derivative of the low, well, the derivative of x is 1. All over the low one getting squared. So I'm just going to square that immediately. Sometimes it's fine. So this is, I'm going to erase this. This is the same as x times x. And sometimes that actually is better. But on this problem, I am just going to square it just to show it like that. Okay, and then so there's our derivative. And then, well, just like most derivative problems, once you do the derivative, then there's usually steps to simplify. So I'm going to simplify this as f prime of x. Well, x times 6x would be just 6x squared. And then I have minus, so the minus would distribute. The 1 would also distribute, but the 1 doesn't really change anything. So the negative, I would have minus 3x squared minus 5 like that. And then x getting squared is still x squared. Okay, and then one more time, I have let's just put it next to it. I see I have like terms. 6 minus 3 is 3. Attach the x squared minus 5 all over x squared. There it is. Okay, so that's using the quotient rule on this problem. Well, you might have saw it before I jumped into it. Note that the denominator is a monomial. So often, it's easier to rewrite this problem and do it like this. So that's if it's a monomial in the denominator. We usually rewrite it. It's usually faster. And let's show it real quick. So I can simplify the 3x squared over x as just 3x. And then that would become 5x to the negative 1. And then doing its derivative, I would get 3 minus 5x to the negative 2, or 3 minus 5 over x squared. Okay, and we can see, hey, these look a little different. However, they are not. Okay, these are the same. So notice if I were to take this x squared and divide the 3x squared by that x squared and then divide the minus 5 by that x squared, it is the same. Those x squareds cancel and it is this. Okay, so this one I think is a little faster. So again, if it's a monomial in the denominator, I would recommend doing it like this. It's faster. But for now, I wanted to show the quotient rule because like in number 2, we must use the quotient rule. So the quotient rule has to be done there. All right, so let's show that. Let's see it. Okay, so here again, I'm going to use the quotient rule to help us on this problem. So I'm going to keep my colors here. So my high one is the t cubed. My low one is that whole thing there. All right, and with this, I'm going to jump right into it again. I think we could just look at these and see it okay. So my h prime of t. So I'm going to write out the formula, my low d high minus my high d low all over my low low. And then from there is usually when I like to put in my parentheses. So low times the derivative of the high minus the high times the derivative of low. And if I'm using colors, let's go ahead and color code the lows, the low portions like that. Okay, and then now let's jump into doing the derivative. So my h prime of t is, so the low is t squared plus 1. The derivative of the high is t cubed. Or not, the high is t cubed. The derivative of the high, 3 would come to the front, minus 1 from the power to get 3t squared. And then we have minus just the high function, just t cubed. And then our derivative of the low, well, that one I think we could do without scratch work. 2 comes to the front, and then t's attached. Derivative of 1 is 0, so it's just 2t like that. And then we have our low one getting squared. I'm going to write it, so just to show you could do it like this, and then afterwards we usually would say, hey, if the same thing times itself, we would just write as squared. Okay, so there's the whole setup, and then from here it's just like what we always do with derivatives. Look to simplify, so this 3t squared would distribute. So we'd have 3, let's go ahead and get a big fraction ready. So 3 t squared and t squared is t to the 4, and then plus 3t squared. And then in this one, it just multiply, so I have minus in front. 2 is the coefficient. T cubed and t would be t to the 4. And then down below, let's go ahead and change that to be t squared plus 1 squared. Okay, so I give myself an extra long fraction bar. Doesn't really need it. But now I look at the numerator and I see, oh, there's this and this that are like terms. So let's combine those. So we have h prime of t is 3 minus 2 is 1. So it's just t to the 4 plus 3t squared over the t squared plus 1 squared, like that. Okay, and this is an answer. This is fine. Sometimes, though, if you can, they like to factor. So notice t squared's in common. So we could have h prime of t is, so t squared I could factor out of these, and I'd be left with t squared plus 3. And then the denominator is fine, though, t squared plus 1 squared. Okay, so often they like to factor when they can. So on this problem we could, so might as well. They also usually do not multiply the denominator out, so they usually just leave it in this form. So the denominator is usually the nicest part, where we just rewrite it a bunch of times, as many times as needed, but we don't actually have to multiply it out. Okay, so either way, these are both good. This is, I think the factored form is maybe a little nicer down the road. So if you see something that could be factored, try to factor it. Okay, so let's see some other cases. Let's do two others. Okay, so on number 3, we have a little bit more complicated expression here. And on this, I'm going to make an adjustment right now. Let's just put an X on that 3. Okay, so I want to change this problem. So I'll change that. If I remember, I'll change that in the typing. Let's make it like this to make it a little harder. Okay, anyway, so what we have is we have the implied parentheses, and we have really, let me put it in blue, this is our high, and then this is our low. Okay, with this, let's go ahead and still set up our equation. So our derivative of y with respect to x is, I'm just writing the formula out, our low d high minus our high d low over my low low. Okay, and I usually do that in blue. Let me at least just put this side like that in blue. Okay, so just to show, I'm setting up my derivative equation. It's ready to go. And then afterwards, so dy dx is, let's get a big fraction. I'm just kind of setting everything up. On this, though, again, if the problems get a little bit more complicated, I'm just going to write this to the side. Like the high is 5x squared plus 3x. The derivative of the high would be 10x plus 3. So it might be useful doing this in case these start to get hard. And for instance, like the low, I probably shouldn't just eyeball the derivative and put it in. Here's where it's good to rewrite it. So the square root of x minus 1, I would rather see x to the 1/2 minus 1 is the low. And that way I can do its derivative easier. So the derivative of the low would be 1/2 x to the negative 1/2, and then that's it. Okay, so we have our setup, and then now we can start to plug everything in. So the low and the d low, I'm just putting those in red, and then our derivative of the highs and our highs we'll keep in blue. Okay, so I have my reference over here to start plugging everything in. So my low, I'm going to use the half power, so x to the 1/2 minus 1 times the derivative of the high, which is 10x plus 3. And then we have minus our high portion, just the 5x squared plus 3x, times the derivative of the low, which is that 1/2 x to the negative 1/2. Okay, and then all over the low. So low is x to the 1/2. This time around, I am just going to go ahead and say x to the 1/2 minus 1 getting squared. Okay, so there it is. So so it's mostly knowing the formula and being able to find these derivatives and then plug it all in. And then now that we have it, well, then again, it's just going to be simplify. So dy dx is, I'm giving myself a big fraction bar. Here I would need to FOIL. Okay, so the x to the 1/2 multiplies the 10x. That would be 10x. 1/2 plus 1 would be 3/2. And then x to the 1/2 multiplies the 3, so that would be positive 3x to the 1/2. Then the negative 1 also distributes, so that would give us negative 10x, and it would also give us minus 3. Okay, and then in this step, so be careful here, I'm going to do two things in one. The negative will distribute, so that's going to change them into negatives, while at the same time, this 1/2 distributes. So it's double distribution. Okay, so but the negative's easy. It really just makes sure to say, hey, just make sure the signs are opposite. So I'm going to set this up as minus. 5 times 1/2 would be 5/2. X squared and x to the negative 1/2, those powers add. 2 plus a negative 1/2 is really 2 minus 1/2. which would be 4 halves minus 1 half, which is 3 halves. Okay, so it's x to the 3 halves. And then again, the minus distributes, so I'd have minus 3 times a half would be 3 halves. And then x times the x to the negative 1 half would be really 2 halves minus 1 half, which is 1 half. So positive 1 half power at the end. And then down below, I still have, I don't know, the 10 I saw first on the left there. So sorry, so it's really just x to the 1 half minus 1 getting squared. Okay, and then now, again, just like most of these problems, I want to go through it and see what simplifies. We have 10x to the 3 halves minus 5 halves x to the 3 halves. So those would combine. And then let me use my highlighter still. I have positive 3x to the 1 half and the minus 3x to the 1 half. Those would combine. Okay, so what this becomes is our dy dx is, set up a big fraction. That should be good. Now, I'm going to go ahead and just change these to decimals. So negative 5 halves is the same as 2.5. So 10 minus 2.5 would be 7.5. And then attach the variable x to the 3 halves. Okay, so that's my choice. You don't have to do that. You could leave it as fractions, but I thought at this point I would prefer to use decimals. It's a little easier for me. Okay, and then in the pink, I have the positive 3 minus 3 halves. Well, 3 halves is 1.5, 1.5. So 3 minus 1.5 would be 1.5. And then x to the 1 half power is still attached. And then we still have minus 10x and then minus 3. All over this denominator, x to the 1 half minus 1 squared. Okay, and then that's it. So we got it. Okay, so that's how we could find that answer. And again, you could even change the 3 halves to 1.5 and this 1 half into 0.5. You might want to change the order because this x has a power higher than 1 half, so it might be better to write that second. However, those are kind of optional things, and I think this is just fine for our final answer. Okay, so let's do one other. Okay, so on our last one here, we've got this expression. Well, this is still the high. Right there is our high. And then this is our low. And so I'm going to set it up again. So I see it's a quotient. So I would use a quotient rule. F prime of x is our low d high minus our high d low all over the low low. And then from here, I've got my parentheses. And then again, I usually do my derivative in blue. At least let's put that in blue. Okay, so I set up the equation immediately. And then on this one too, I'm going to use this space to write out my high and low function. So there's the high, and then the low is 4x plus 3. Let's do the derivative of the low first. That's real easy. That's just 4. Okay, the derivative of the high, this requires either us to multiply or to use the product rule. I'm going to use the product rule. Okay, so where this, now I'm going to keep this colors. This is u and v. So the derivative of the high would be u, v plus u, v. And again, remember, I usually write it like that. And then afterwards, I make sure to alternate the prime. So u prime v, u v prime. Okay, and then now I'm going to plug all those in. So the derivative of the high, u prime. So I can see this okay. So the derivative of this would be just 4x. And then v is just right after, so 5x plus 2. And then plus the u, which is the 2x squared minus 1, times v prime, which is really just 5. Okay, and then now we would probably multiply this out. So the derivative of the high is, okay, so 4x times 5x is 20x squared. 4x times 2 is 8x. And then 5 multiplies to give us positive 10x squared minus 5. And then I'm going to put our kind of final answer of the derivative of the high over here. I see I've got like terms. It would be 30x squared plus 8x minus 5. Okay, so there's the derivative of the high. Okay, so sometimes it takes a little extra time. So this is a quotient rule and a product rule problem. However, everything is now ready to go. So our f prime of x. All right, so the high portions blue, my low portions red. There it all is, set up well. And then now I'm just going to plug everything in. So let's set up a big fraction bar. Hopefully that's enough room. And our low, so our low is the 4x plus 3. The derivative of the high was that blue expression that's clouded over there. So the 30x squared plus 8x minus 5. And then we have our minus the high portion, which is this, the 2x squared minus 1 times 5x plus 2. And then the derivative of the low, which is just 4. Okay, all over the low one, 4x plus 3 times itself, which would be 4x plus 3 squared. Okay, so there it all is. So we found it all. And then now it really is just the rest of it is simplify. Okay, so be careful. Take your time. Let's show how it works. Okay, so I'm going to do an extra long fraction bar. And then let's just go ahead and take care of the bottom. 4x plus 3 squared is ready. Okay, so I need to distribute a lot of stuff. So on this one, this 4x is going to multiply all three of those terms. So we've got 4 times 30 is 120. X and x squared is x cubed. Then 4x times 8x would be positive 32x squared. And then 4x times negative 5 would be minus 20x. And then this positive 3 would also multiply all of them. Let's go ahead, I'll do that one in blue. So positive 3 multiplies those three terms. So positive 3 times 30 is positive 90, and then attach x squared. 3 times 8x would be positive 24x. And then positive 3 times negative 5 would be negative 15. Okay, so there's that. And then now, we have to be careful of this, so I'm going to put it in green. This minus will want to distribute after all of this has been simplified. So I'm going to do minus parentheses, and hopefully that's enough room for all of this to FOIL. Okay, and we will FOIL the blue portion first. So we will FOIL this right here. And then the 4 will eventually multiply afterwards. Okay, so let's go ahead and FOIL this real quick. So 2x squared times 5x is 10x cubed. 2x squared times positive 2 is positive 4x squared. Negative 1 times 5x is negative 5x. And then negative 1 times 2 is negative 2. And then the 4, now we can distribute that through in this next step. Okay, and let's actually also distribute the negative. So I'm going to do two things in one here. Let's distribute the negative all the way through. Okay, so what we have, so our f prime of x is equal to, let's go ahead and try to draw a horizontal line. Sometimes I have a tough time with the computer pen. Not bad. Okay, so that's our big fraction, and then still just 4x plus 3 squared down below. And then I'm just going to go ahead and rewrite, well, I guess we can simplify some of this. Let's simplify what we can. So it looks like I have a positive 32x squared and a positive 90x squared. And I also have a minus 20x and a positive 24x. So we could do a bunch of simplifying in one, actually. So we still have 120x cubed. And then the positive 32x plus 32x squared plus the 90x squared would be plus 122x squared. Minus 20x plus 24x would be plus 4x. Minus 15 is still minus 15. And then now let's distribute the negative, while at the same time multiply by 4. Okay, so that means the negative is going to change the signs, and then the times 4 will times the coefficients by 4. So it looks like we'd have minus, so this is now negative. 4 times 10, though, is 40. So minus 40x cubed minus 4 times 4 is 16x squared. Negative and a minus would now be plus. 5 times 4 is 20, and attach the x. Negative and a negative is plus. 2 times 4 is 8. Okay, so now one final step. So way to hang in there. So we now can do one more simplify. So it looks like I have 120x cubed minus 40x cubed. It looks like I have 122x squared minus 16x squared. And it looks like I'm going to run out of my highlighter colors. I guess I'll just do all different colors, highlighters. So the minus 4x and the plus 20x. And then let's just leave that unhighlighted. We'll just say that looks good. Okay, so the minus 15 and the positive 8 we could see would combine. So finally, our f prime of x, 120x cubed minus 40x cubed would be 80x cubed. 122x squared minus 16x squared would be plus 106x squared. Positive 4x plus 20x is positive 24x. And then the minus 15 plus 8 would be minus 7. And then still 4x plus 3 squared underneath. Okay, and since I can, let me just make it look a little better. Okay, so there we go. So that's as rough as these ones get. Okay, so if you were doing fine on this one, I think you'll be fine on all quotient rule problems. But they can be difficult. Okay, so the main thing I would still say is write your formula out first, and then start subbing things in, and then just know, hey, sometimes it's going to take some time to simplify. But you got it. Just stay patient. Okay, that's it for now. So thank you for watching, and I will see you again next time.